the terrestrial, the land developmental stage of a eastern newt.
A newt?
It's a stage of a newt. So eventually, after walking around on the ground for about 5 years, it'll go back to the water and turn into a newt. So and then the newt will give birth to these larvae in the water, and then eventually they'll shoot up onto the land and wander around like that for 5 years. So those are really cool creatures.
Yep, that's why you have to be careful with them.
The garlic mustard is one of the worst invasives that we have here. And it spends its first year just like a little leaf like that, and it spends its second year growing up into a big plant about the size of this jewelweed, and it produces tons of seeds. And if you grab one of these leaves and rip it and smell it, you can actually smell the garlic in it. It was brought over here as a pot herb by early European settlers, and it just really enjoys it here. What you can see is probably these little white filaments going through the soil, and they're either roots or they're mycorrhizal fungus. A mycorrhizal fungus is a type of fungus that attaches to the roots of trees, and it actually expands the surface area of a tree root. And it's what we call a symbiotic relationship, because the fungus feeds off of sugars that the tree roots produce, and the fungus actually, like I said, increases the surface area of the tree roots, so it brings in more water and nutrients from a greater distance. So one tree could have, it's hard to believe, but 1,000 kilometers worth of roots. Because if you think of one root, then another root coming off of it, then another root coming off of that, then more all the way down. If you line them all the way down the line, you'd have about 1,000 kilometers or more. And these mycorrhizal fungus attach to those roots and just make it even more, even a bit bigger surface area. So it's a very interesting symbiotic relationship.
Look, it's puffy! Can I puffy now?
Oh, sure. Just don't breathe it in.
You'll have mushrooms growing in your nose. I'm breathing this out.
And the white.
Is that quite a name?
It's called doll's eyes or baneberry, white baneberry. Can you hold that there, please?
Is the red got red berries?
Yep, the red has red berries. And they're just really neat looking fruits because they do look like doll's eyes.
Right?
They sort of carpet the understory in a lot of the property. It's called sarsaparilla, and it actually was used back in the days. The settlers used it as sort of like a root beer. You know sarsaparilla? That's the same, it's a different plant than sarsaparilla is traditionally made from, but this is the North American version of sarsaparilla they found. Apparently the roots, when you crush them up and turn them into some sort of drink, taste like a root beer. It's this thing right here. So we've got 5 leaves, and there's 3 leaflets coming off of it. This may well have been the red baneberry. If you see one with the red berries, then I don't know.
This would be red baneberry. Thanks, but it has a flower, not a berry.
The berries are gone. There's a patch of wild ginger. Oh. Which is, now you shouldn't really be digging stuff up, but for educational purposes, I'm going to pull up a plant and pass it around so you guys can see what I mean. It is actually a ginger. You can see the leaf. Smell it. Beautiful blossoms in the spring, yeah. And I've actually read that it's one of the most, or the most medicinal type of ginger.
Oh, wow.
I don't know what it's used for, but it's apparently really good for you. And if you grate it up, you can use it just like the ginger that we're... It's not supposed to actually be here. This is a piece of granite from the Canadian Shield that was brought here by a glacier. And it's a glacial erratic. Exactly, yeah. We are standing on the escarpment, but you can't really see any of the steep cliffs of the escarpment that you typically see elsewhere, because this place was likely covered by glacial till, which is basically when, you probably know, like glacier pushes all kinds of material up while it's moving forward and then dumps it. So these ridges that we're walking up are just filled with glacial till. And there's 2 main ridges along the property here that probably happened as the glacier stopped at one point and then receded a couple times, dumping these 2 large pockets. And granite, this granite is likely a combination of quartz, mica, and feldspar. Is that right? Are you guys a geologist?
You can get away with anything.
And one thing that is interesting about it is that because of its pH, I believe it's more acidic than limestone. Lichens will grow on it. The lichens will grow on the granite. The lichens will not grow on the limestone that's typical of the escarpment cap. You'll be able to tell. And the nice pink hue is also a good tip-off. But the thought of a huge glacier sort of coming by and just spitting this out is pretty impressive, considering it's a massive piece of rock here. This is a hemlock tree right here. And a hemlock tree is a climax species, which means that it's the peak of ecological succession. The peak of ecological succession. So it's a climax species, meaning that it sort of waits, it needs shade in order to germinate and in order to grow and thrive, and then eventually it'll turn into dominate the entire forest, essentially being the one single species. There's 3 species of trees that are climax species in Ontario. Those are hemlocks in southern Ontario, hemlock, beech, and sugar maple. And all 3 of them are here on this property. In fact, we've got a nice big sugar maple right there. As we go down, we're going to take that path down that way eventually, and there's a huge nice beech, American beech as well. So those 3 species represent these climax forests. One thing that's interesting about a climax forest is that because these trees are shade tolerant, they can wait for up to 200 years. A hemlock can wait for up to 200 years before it has a canopy gap and will shoot up becoming a nice tall tree overhead.
Right above the canopy.
We've got some turkey vultures growing around, yeah. But you can also notice that if you look down, there's not a lot growing underneath in the subcanopy because the hemlocks produce such a dense shade. So one of the results of this climax community is not a lot of diversity. So you need some sort of natural event to push down the hemlock, would it be a disease or a windfall or a tornado or something like that, and to wait for a canopy gap that would allow sun-loving species to come back in and start the succession all over again. The American beech, which is the second tree in the 3 climax species, and you're probably familiar with these, but the one way that people tell that they're a beech is it kind of looks like an elephant's foot, an elephant's leg. You got the toes down there and all these kind of knees, knobbly parts. But they're really nice trees, and they retain their leaves in the wintertime. They turn brown and kind of retain their leaves. I've actually seen a variation of a beech used as a front hedge, which was really nice because in the wintertime it just turns this brown color, but it still provides sort of this protection, you know, a little bit of screening. And right now they're dropping nuts. We may not see any here, but just around the bend or a little farther down the trail, you can see a whole pile of beech nuts, which are edible and they're kind of tasty. I don't know if they're properly aged right now.